All right, so I went ahead and put the solutions here as well as where I always put them. And a couple of these were kind of interesting. I forget which ones they were, but let me find out where. There was something I wanted to point out, and I can't remember where. So like for 29, let me get the other place because this, I can't zoom this in as easily. Well, actually I can. I remember how to do it. All right, so for 29 here, sometimes factoring out first is a good idea because then you don't have to deal with all those big numbers. And so factors of 5 times negative 36, they combine to be negative 24. This is what I'll do when something like that happens. I'll go ahead and I'll break these apart into smaller factors, and that usually works. And you can see, yeah, it did. So 30 times 6 will work out to be negative 24. Okay, and then notice the FOIL, reverse FOIL. So you need a 5 times a negative 6 to get negative 30. And then this would be the inner product, the 6x squared. Yeah, and then if you don't have to use the zero property, then by all means, it's not necessary. I'll get to that point in a minute. So 61 here, when you factor it, you got some more you can do because the 4x squared minus 1 is a difference of 2 squares. So that's why I broke it down again. All right. And 63 was interesting because if you factored out the 8 first, then you could do your difference of cubes and you get what you have here. Or if you didn't do that, so I did it both ways, then you would get this expression, and it looked to me like there was a whole lot of multiples of 2 and 4. So I pulled out a 2 from the first binomial, and then I pulled out a 4 from the trinomial, and you still wound up with the same thing. So if you factored out the 8, that wouldn't have been an issue. Okay, and then here, sometimes factoring out, and then you got your difference of cubes. There was a point I wanted to make. Yeah, so notice how helpful the zero product property is. And now when you have your equation equal to 0 and you're doing your sum or difference of cubes, the trinomial is never equal 0. This trinomial will always wind up being the square root of a negative. I have not yet found one exception to that. It's interesting how that is, but if you think of the graph, if we looked at this x cubed plus 27 as a graph, right? And that would be the y-intercept of 27. And since we know that x was negative 3, this is going to do something like that. Notice when you take the derivative of this, you get 2x squared. Right? So that means right here at the y-intercept is where we get that to happen. And since there's only one x-intercept, it can't come back down and touch the bottom of the graph. What am I doing? Right? So what it probably does is something like this, right there at 27. So when you have that trinomial from the sum and difference of squares, this one's never going to be able to equal 0. And this is one of the reasons why. Because anytime you have something in this form, your derivative is always going to be 2x squared. So you're not going to get two humps, which means this isn't going to come down and cross, which means that's never going to equal 0. All right, so I mean, it's just something I wanted to point out. What was I trying to do? Oh yeah, share screen. Okay. Now with 77, you really didn't need to factor that because you might as well just add 1 divided by 8 and take the cube root. There's really no need to factor that since you're just solving an equation for 77. And notice with 83, when you divide, you're trying to find x to the 6th equals a negative. Well, anytime you have an even root, you can't have even roots of negatives because that means you could multiply something 6 times to get a negative. That's not possible. And yeah, and then over here, I didn't factor the difference of squares here because we're just solving an equation. And so if you're just solving an equation, there's no need to factor these differences of squares. So add to square root. Don't forget your plus or minus. Okay. And then there were a couple here that I'm sure were tricky because some of them had 2 variables, right? And again, I think starting with 28, you had to use the 0 placeholder. Right? And this is one of them where it actually did matter. And so whenever you get a 0 remainder, that means the divisor and the quotient were factors of the original problem. It's called the dividend. So just to make sure that's clear what we call these things, okay? What was the one I wanted to point out? I guess I probably did. Yeah, okay, so here, once you got to 34, you know, assuming everything else was okay, this could have been tricky. So here, using a 0 placeholder for x and y turned out not really to be necessary, but where would you put the quotient if you needed an x and y? So actually they did come in handy, right? And then first we want to get rid of the 3x squared, so multiplying 3x, distributive property, and then we got a term here to subtract the negative 6xy. And now we want to get rid of the xy, so we need to multiply this by 4y. And then we get the minus 8y squared, and then we get a 0 remainder. So that's how that worked out. Okay, and 36 is and 35 for one of the reasons why we have to learn this, because there really is no shortcut. Because the divisor here is nonlinear. Let's see, there's the other one. And yeah, with the trinomial, it's no different. Just worry about the first term. So, and then just do the distributive property to get the other terms. And then you'll be able to do that succinctly. So then here I had the 2x squared, so I multiplied a 2, and then we wind up with a 0 remainder. And again, when you get a 0 remainder, that means the divisor and the quotient would have multiplied to get the numerator. And that's what that means. There's no remainder. There's no leftover fraction part. Right? And that's just like regular numbers too. Like if you divided and you got no remainder, right? So if you divide 10 by 2, you get 5. So that means 5 times 2 is 10. We call this the dividend. Oh, so part ready to push the end button. Oh, my mind isn't all here today. I'm probably still in shock. My face hitting the concrete.